Yeah, that's right. This is a coffee-powered math lesson. Let's do this, mathletes. Come on. All right, here's your warm-up. Let's get into this. Take a minute, do it. Pause me, because I'm going to start in just a second. Boom, let's do it. All right, are the ratios equivalent, right? Yes or no? You may not even know what equivalence means. It means they're the same, basically. We can simplify them to the same thing. So 3 to 5, all right? That's great. Another way you could write that as is 3 over 5. And we want to know, is that the same as 9 over 15? Well, one way you could do it, is there anything I can multiply 3 to get 9? Yeah, times 3. And would I multiply the same thing on the bottom to get 15 times 3? Yep, I would. So guess what? They're equivalent. The other way I could have done it is I could have said, hey, what goes into both 9 and 15? 3 does. 9 divided by 3 is 3. 15 divided by 3 is 5. Is that the same? Yep, 3 over 5 equals 3 over 5. Let's do the same with this one. I've got a 16 over 6. And let's see if it equals 8 over 2. First of all, what goes into both 16 and 6? 2 does. 2 goes into 16 8 times. That looks promising. 2 goes into 6 3 times. Uh-oh, 8 over 3 is not 8 over 2. Nope. So right now, let's pick a good green color. All right. That's a yes. That's a no. Red light or green light, red light. Let's try this one. Does 6 over 9 equal 8 over 12? I don't know. What goes into both 6 and 9? 3 does. 3 goes into 6 twice. Goes into 9 3 times. What goes into both 8 and 12? 4 does. 4 goes into 8 twice. Goes into 12 3 times. Is that 2/3 equal 2/3? Yep. So let's green light it. How about this one? We've got 12 over 32. And does that equal 6 over 24? Let's find out. 12 I can divide by 2 is 6. 32 divided by 2, so I got to divide it by the same number, right? 32 divided by 2 is 16. Oh, that's 6 over 16, not 6 over 24. That's a red light. I love highlighting it. I like highlighting in real life, though. I don't know. Something satisfying about it. Brandon has ended the season with 30 hits out of 93 at-bats. Ooh, that sounds like a ratio. 30 hits out of 93 at-bats. Mario ended the season with 20 hits out of 62 at-bats. Which player has the higher batting average? That's hits divided by at-bats, which I already have set up. Well, let's simplify them. So 3 goes into 30 10 times. And it goes into 93 31 times. Okay? 2 goes into 20 10 times. Ooh, that's promising. 2 goes into 62 31 times. Uh-oh. Which one has a higher batting average? Neither, because they both are the same. So they have, it's a word question, got to have a word answer. The same average. All right. Today we are talking about solving proportions. And it's really not that hard. In fact, there's a nice little shortcut. Some of these slides you're going to notice me gloss over a lot of it because I like to teach it just a tad different. But let's move on. Right there. We'll reload time. Okay. Found a way to scale this the other day. This is kind of cool. Look at this. This is an actual dude at a car company that's putting out a car model. And what you got to know is, yes, this is smaller, but this car is an exact proportion to the real car, just smaller. So everything is exact. The size of the windshield, size of the light, size of the wheels, everything's identical, but smaller. Scale models allow you to create a representation of a smaller or larger object that may be easier to manipulate and measure than the actual object. For example, an airplane manufacturer might create a scale model before building an actual airplane. This allows the manufacturer to design certain aspects of the airplane at a much smaller cost than working on the actual airplane. Scientists also use scale models when objects are very small. They can construct scale models of the object that cannot be seen with the naked eye. So we use the ratios, we use proportions to either upscale things or downscale them, right? Like I was saying, scientists, if they want to look at a molecule, clearly that's pretty hard. So what do? They create models that are, thousands and millions of times bigger than an actual atom to be able to look at the workings of it inside. In the same way, if you're a manufacturing company and you're creating a brand new product, you don't necessarily, let's say use their example, or let's do a different one, a car company. I know they talked about cars, but let's say a car company wants to make a new type of car with different aerodynamics. Well, instead of building this huge concept car and testing aerodynamics on it, they build a scale model of it, test the aerodynamics on the scale model, get everything right, and then they'll build the big model. Yes, there might be little differences, but honestly, they can save millions upon billions of dollars doing that. So these are ways we use proportions. It allows us to really compare two quantities. So, let's see what we got here. This is kind of cool right here. So you'll notice we have an actual cost and a sale cost, okay? And I can actually scale them and move them around, but let's put in a couple of numbers. So right here, all right, I got $295 for the original price, and I have $236 for the sale price. Let's move it around a little bit, because supposedly this is the same type of a sale. It's not changing. I'm just changing. What I'm doing is I'm really changing the overall starting cost, and that's going to change the sale price. Let's try $175 for the original and $140 for the sale. Let's do one more value here just to make sure we're not crazy. Let's do $65 for the original, and that makes $52 for the sale. And here's what's cool. I wish this thing gave me a calculator right here, but that's okay. I use my calculator on the other screen. I take 295 236 and divide it by 295. If you take the discounted price and divide it by the original price, it tells us how much of the actual cost we're paying percentage-wise. So I'm over here on my other computer, on my calculator, and I'm going to do 236 divided by 295. Wow, that came out nice. That came out as I'm going to be drawing out here, that came out as 0.8, which equals 80%. So we got a 20% discount, and our sale, we're only paying 80% of the actual cost. Well, let me try one of the other ones. What's 175 divided by 140? Seems like it'd be different because the other one is like, I don't know, it's almost $60 apart, and this one's only $35 apart, right? You want to know what's crazy? So when I do 140 divided by 175, it's still 0.8. Still 80%. Why would that be the same? It's because I'm taking 80% of a smaller amount, so it's going to be less of a discount, but it's still the same percentage discount. In the same way, let's do 65 divided by 52 just to confirm this. I'm sorry, I said that wrong. 52 divided by 65. I even typed it wrong. Look at that. It's 0.8 or 80%. So we know without a shadow of doubt, even though we're changing the starting cost, I don't know why I do that. Even though we're changing the starting cost right here, the sale is still just going to be 20% off, making us pay a total of 80% of it. Okay? All right. I think that is awesome. I think there's anything else down here. Yeah, not that we're going to do. Solving proportions. Here's what we're going to talk about. The cross products of proportions are equal. All right, I want everybody to write let me just underline this. Or here, I'll highlight it. Go ahead and write cross product property of proportions. And we do want to write down the words. The cross products of proportions are equal if A over B equals C over D, then AD equals BC. And our explanation is right here. If we have 6 over 8 equals 21 over 28, then what we're going to end up doing is we're going to, everybody say cross multiply. We're going to cross multiply. And we get 6 times 28 equals 8 times 21. And look at that, it's true. 168 equals 168. So we know that those are proportional. We're going to use this to solve a lot of problems. Go ahead and take a minute, write that down, and we're going to get moving. So let's see. How can we use this to solve equations? Well, what if we have something that says, all right, 15 over 6 is equal to 25 over x. We don't know what that denominator is, but we want it to create an equivalent fraction. Well, then I would do the same exact thing. I would cross multiply, just like that, okay? And when we do, what do we get? We get that 15 times x is equal to 6 times 25. And when we solve that, we get 15x equals 6 times 25 is 150, right? 6 quarters makes $1.50. And now I can solve even that, because how do I undo this? Well, I have multiplication times 15. We undo that with division, and we want to get rid of the 15 so x can be by itself. X is like, get out of here, 15. I'm going to divide you. It's like a knife fight, right? And then we get x equals 10. And let's see if that works. So does 15 over 6 equal 25 over 10? We could always cross multiply. 15 times 10 is 150. 6 times 25 is 150. Another way you could check it, if that doesn't hit with you, is what goes into both 15 and 6? 3 does. 3 goes into 15 5 times. Goes into 6 twice, right? That can simplify to 5 halves. What goes into both 25 and 10? 5 does. 5 goes into 5 5 times. Goes into 10 twice. Look, they're both 5 halves. So those are different ways we can prove that it is indeed proportional. We call that being proportionate. And I'm telling you, between tables and proportions, you can get through a lot of math if you're really stuck. Keep glancing over here at my clock that's still stuck on 10:25 or 26. It's not 10:26. It's just what it says. All right, looks like we just ramped up the difficulty a little bit, but it's still not that bad. And it says round to the nearest hundredth, so we can do that. So if I have 2 over 8 minus x equals 5 over 13, I'm telling you they're equal, so let's cross multiply and prove it. So 2 times 13, that's pretty easy, right? 2 times 13 equals, what do we do here though? We got, remember, it's like this has a parenthesis around it. So we're going to write it like that. 5 times the quantity 8 minus x. Now we're cooking with peanut oil. We got to distribute that, right? So what we're going to end up with, 2 times 13 is 26 equals 5 times 8 is 40 minus 5x. Got to multiply times that 5. All right, let's do this. I'm going to go ahead and subtract 40 from both sides. I know some of you are thinking, oh, but that's a negative 5. We'll deal with it. Minus 40. And this is a war. How much is 40 going to win by? First of all, 40 is negative, so this is going to be negative. 40 is going to win by 14. Equals negative 5x. And I'm going to divide both sides by negative 5 so I can get x by itself. That's how we deal with that negative. What do two negatives make when we're dividing? A positive. So we have 14 over 5, which is going to be, I believe, 2.8. Do we have 2.8 up here? So we have 2.8 equals x. Boom. Right here. It's B. Pause it if you need to. We're moving on. Really, proportions is just all about solving. We're just going to solve a lot of proportions. You get a lot of practice in your homework today. And it doesn't even matter if they look ugly like this because we're still going to cross multiply. And when I cross multiply, look at what I get. I'm going to have 9 times 2x minus 5. So 9 times 2x minus 5 equals, I'm always going to put the smaller number first, 4 times 4x plus 3. 4 times 4x plus 3. Don't let these trip you out. It's just steps. All I did is write these two things next to each other, one in a set of parentheses. Now I'm going to distribute. I'm going to distribute once with the 9 and once with the 4. Drawing lines helps me remember what to do. 9 times 2x is 18x. 9 times negative 5 is negative 45. Equals 4 times 4x is 16x, and 4 times positive 3 is positive 12. All right, what side do we want to get the variables on? I choose left Pikachu because it's going to stay positive. So I'm going to have minus 16x. Minus 16x. Sorry, I hope the words don't mess with you that I'm writing over them. And you know what? I'm going to choose a different colored pen, but I'm going to do also, if I know I'm moving x's over to this side, I have to move my negative 45 over to this side. How do I move a negative 45? I'm going to add 45 at the same time. Might as well kill two birds with one stone. Plus 45. And what do I end up with? I end up with 18 minus 16x. 18x minus 16x is 2x. Boom. 45's cancel out. Equals 16x's cancel out. 12 plus 45 is what? 57? Is that true? I think that's true. Wow. I'm going to divide both sides by 2. Which, if you divide that out, it says nearest tenths. It's already going to be nearest tenths because when I divide that, it's going to end up being, what? 25 is half of 50, and 3.5 is half of 7. So that's going to be 28.5. All right, I got to know, did I do it right? Are you ready? Pause this, write this down, because all this is about to disappear. 28.5. Check it. Yeah, that uncomfortable noise. All right. I actually like proportions. They're fun. I like solving algebraic problems. I don't know. It's my thing. I'm weird. I never said I wasn't. Solve a proportion by using a constant rate. Parts of Mexico City are sinking at a rate of 140 centimeters every 5 years. So, this sounds like a proportion already. 140 centimeters. Sometimes units help you, by the way, every 5 years. Because they help you make sure you put the right things on top and bottom. If this remains constant, how many centimeters will the city sink in the next 12 years? Well, remember, years is on bottom, so we want this to be, this proportion needs to be equal to, we don't know how much sinkage over the, but we know it's centimeters, over the course of 12 years. Since I put years on bottom over here, I have to put years on bottom over here. Now let's cross multiply. What do I get? 5x equals 140 times 12. I don't know off the top of my head. $1,680. 1,680. Ooh, it ends in a 0, so I know this is going to come out nice. Because when you divide by 5, it goes into anything that ends in 5 or 0. Except for 0, I guess that is true. So, what's 1680 divided by 5? It's 336. So, x equals 336. 336 what? Centimeters. We need to write an answer, word answer, right? So, first of all, get this written down. I'm about to make it disappear. Ready, set, go. I'm doing this because we solved the proportion, but, oh, it solved it. I wanted to write something. Oh, okay, here's what I would write. in 12, I didn't want to use the drawing thing to do it. In 12 years, the city will sink 336 centimeters. Boom. Look at that. Nice sentence. Tylo package. We got this. And that's how you use proportions, by the way. They actually use that to do like surveying and stuff like that. We see people surveying on the side of the road, and they're seeing how much the flags have moved. And what they do is they say, all right, if it's moved this far over the course of maybe, say, like a month, then they can estimate how much it's going to move over the course of a year, 2 years. So they know when they need to plan for the next construction, or they know they need to shore it up so that it stops moving and eroding. All sorts of stuff used for that, especially in Oregon. We have nice roads here. I'm telling you, I used to live in Virginia, man. Oh, man, I used to get car sick just driving. It was, and it happened because it would freeze in the middle of the night and then thaw out. And so it would cause these cracks in the pavement, and oh my goodness, it was rough. All right, now some of the problems can be a little more challenging. We got to think about what it's asking us. A guide company makes a trail mix of raisins and mixed nuts. How many pounds of raisin does the guide company need to mix with 14 pounds of nuts to make the trail mix 30% raisins? So, what does 30% mean? That word percent actually helps us. That's because cent is the root word of 100. So 30% really means 30 out of 100. So one of the ratios we're going to use today is 30 out of 100. And what we want is we're going to let R be raisins. Be the amount of raisins. So we need to know how many pounds of raisins, right? And we're going to do this in pounds. It's also important to identify the units, okay? Because it's talking about pounds of mixed nuts, we need to do pounds of raisins. So I want to know how many pounds of raisins do I need to add to 14 pounds of nuts to get a 30% mixture, so 30 out of 100 mixture. But here's the deal. If I'm adding R pounds to the 14 pounds, I need to account for that on bottom too, because I'm adding that weight down here, right? It's going to be a total weight. So we've got the part, just the raisins, but we need to have the total weight on bottom, just like I have the part out of the total of 100 here. And now to solve this, let's cross multiply and solve for R. Take a minute, do it, pause me, and we'll start in just a second. All right, I'm assuming you paused it. Hopefully, if you didn't, that's on you, but you need that practice doing this. So I'm going to have R times 100 is just 100R. We always put the coefficient first, equals, and then 30 times the quantity, 14 plus R. All right, let's go ahead and distribute this. I have 100R equals 30 times 14, what is that? 300 plus 120, so 420 plus 30R. And then I'm going to subtract 30R from both sides because I want to get my variables over here and I'd like to keep them positive. And if I do this, I've satisfied step one, which is get the variables on one side, numbers on the other, and I get 70R equals 420. Now, to get R by itself, we've got to undo this multiplication. I'm going to divide both sides. I'll use a different color so it'll show up a little bit. By 70. See, it shows up on the black background there. I'm going to divide this side by 70. Whenever you're dividing by two numbers that have zeros, however many zeros they have in common, you can cross out. So this is the same as 42 divided by 7. So I'm left with my R. My amount of raisins equals what? What's 42 divided by 7? It's 6 pounds. Boom. So I know that I need to add 6 pounds to the trail mix, to the mixed nuts, to make it a 30% mix. Go ahead and write that down. I'm about to take it off the screen in 3, 2, 1. I want to scroll down so I can write. I don't really know what to say there, but here's what I am going to say. I'm not worried about Raja's error. Is there a note I can add? Doesn't let me. I'm just going to use this to write in there. So what would I write about it? I would say the company needs to add 6 pounds of raisins to 14 pounds of mixed nuts in order to make a 30% trail mix or mixture. All right. It's a good sentence, right? Okay, so we're going to do lots of proportions today. Have a good time. You ready? Peace out.